Since the dawn of Redstone, players have been determined to push the game to its absolute limits. From humble beginnings, Redstone computers presented a tantalizing concept to create general-purpose computation machines from simple logic circuits. The early days were quite rudimentary, slow, and bulky, but through persistence and skillful engineering, clock speeds and memory have increased significantly. This all culminated in the realization of a dream that was meant to be a joke, a computer that can play Minecraft inside Minecraft. But what was left to conquer? Well, ladies and gentlemen, it is with pride that I announce a brand new computer architecture, a true magnum opus, a computer that is worse in every way. Yeah, that's right. Drop your expectations right to the floor. The speed is horrendously awful, even for Minecraft. Like, whatever speed you think it should take to add two numbers, this machine takes orders of magnitude longer. For reference, it can take hundreds of instructions to execute a single operation. But really, that's the beauty of this whole thing. Everyone knows how slow Redstone computers are. So what would be better than creating an interpreter for the least efficient programming language? For this project, we're diving deep into the dark underbelly of esoteric programming languages. I'm of course talking about the infamous language, Brainfuck. Its name is well deserved. There's bad programming languages, and there's evil programming languages. To understand Brainfuck's origins and why it's suited to be implemented in Redstone, first we have to answer the question, what even is a computer? I don't want to bore you with the theoretical underpinnings of computer science. The story begins with Alan Turing, an English mathematician who famously cracked the Enigma code and provided a major strategic advantage in World War II. Gee, what a war hero. I'm so glad he got the respect and treatment he deserved. Turing devised an abstract computational model called the Turing Machine, which it turns out is as powerful as any programming language, given infinite memory. But while the model is useful for constructing foundational proofs, it is not exactly the language of choice for software developers. The Turing machine contains an infinite memory tape, or array, which can be mutated according to a table of instructions, known as a finite state machine. The general principle is that the state machine executes a program by moving to different spots on the tape, reacting to the current memory value, and possibly modifying the memory value. These simple rules are sufficient to implement any algorithm, or even simulate another programming language. This is a property called Turing completeness. In fact, we are able to build computers in Minecraft at all because Redstone is Turing complete. So what do we get when we strip down a programming language to bare theory, nothing more than a glorified Turing machine? That's right, we get the demon spawn that is Brainfuck. Brainfuck adapts to the concepts of a memory tape and an instruction pointer. It distills everything down to just 8 instructions. A plus means add 1, minus means subtract 1. The angle brackets shift the memory pointer left and right. The square brackets enclose a while loop that terminates when the memory value at the pointer is 0. The last two are just to read input and print output values. Using arrays to manipulate values is pretty standard, so what makes the Brainfuck experience so uniquely terrible? It all comes down to this fella, the memory pointer. It would be more apt to call it the short-term memory pointer, because once it moves, it has no recollection of the value it just saw. And the memory pointer is the only variable, so erroneously shifting the pointer is a death sentence. Not to mention that we only have one branching condition. Is the value 0 or not 0? This means that in order to check if a value is 9, we have to run subtraction 9 times, check if it is 0, and then add back 9 times to return it to original value. Copying a value is pretty useful, but in Brainfuck, copying a value to a new location destroys the original, so you have to copy it twice. Let's consider a sorting algorithm in 2 languages. Here it is in JavaScript. It requires a bit of programming knowledge to understand, but it is readable. And here it is in Brainfuck. Yeah. Brainfuck is such that even an expert would have to carefully trace out the operations and memory structure. And if you want to change the program, it may be easier just to start over. I hope you can see why I have such disdain for this programming language. But if I hate it so much, why did I spend months creating a Redstone interpreter for it? As Bjarne Stravstrup put it, there are only 2 kinds of languages, the ones people complain about and the ones no one uses. And since I want to complain about Brainfuck, I have to use it. Now let's finally get into the inner workings of the machine. I'll break down each module so you can see how they piece together to implement Brainfuck. This is the instruction module, which uses this flying machine as an instruction pointer. And so the way this works is we have these shifting mechanisms, and so we can move the instruction pointer back and forth. And each time we move it, we'll trigger one of the pistons into a column, which will then execute one of the commands, which in this case would be a subtraction. This is the unit for the memory tape, And you can see here we have a line of droppers, which represent each individual memory value. So right here, we have this one has a value of 3. You can have 0 up to 9, so it's a decimal computer. And we have addition and subtraction operations. We can increment it by 1, and it should be at 4 now. We have a subtraction operator, and that'll be back at 3. And this block here is connected to this flying machine, which we can shift one by one. And so the pointer will move over. And so now the next block will be selected. So if we add 5, then you can see here, now there are 5 values in here. This is where I create and store the programs that will be executed by the machines. The programs are encoded with these observers at different heights, which will be interpreted as different instructions. You can see the instructions here. So this observer represents a shift up, and those ones down there represent an open while. And so you can see we just extend the program as far as we need. This program, I think, is about 150 instructions. And so it just carries down all the way. And then when you want to input into the system, you can just clone it over there. But you can do it in survival. This is the input unit, which again uses a flying machine pointer, which will read from these dropper values using this block. And that will enable us to read in a value from here and put it directly into one of these memory cells. Lastly, we have the control unit for the while loops. Whenever you hit a brace, you might have to send the instruction pointer to the corresponding brace, and that involves ignoring instructions and keeping track of nested braces. And so there's a fair bit of logic right here. And honestly, at this point, I don't even remember how it works. I designed it so long ago, and it's just a bunch of ugly, ugly logic. So just treat this as some sort of arcane magic that is sort of the glue of the system. But I've been yapping long enough about boring nerd details. You all are here to see the machine, so let's just hop right to it. The program that I'm going to be demonstrating is a power of 2 algorithm that takes in an input where the digits are reversed, so this is 26. And once these are input, then the algorithm will go to work and begin doubling the numbers. All we have to do is just hit this lever and that will kick off the machine. There you have it. Starting from an input of 26, the machine successfully doubled the number 9 times. The machine is flexible to handle larger inputs and different algorithms, but it already takes 6 hours to compute as it is. For reference, the fastest Minecraft CPU could do those 9 operations in 3 seconds. So is this machine practical? Absolutely not. But regardless, it was fun to turn theory into reality and explore a totally different class of computational machinery. And if nothing else, I get to say I implemented a real programming language in Minecraft. I hope you learned something, and thanks for watching.